Today we'll be studying the work, actually the positive work and the negative work. For example, if we take some block, here is a block, okay, and this block has mass m, and let's act on this block with some force F. So we're pushing this block to the right. So the block moves with certain distance. We can call that distance x. Let's see, the block moves from point A to point B, okay, and the distance here we just call it x. So the work done on the block is W, which is equal to the force that acts on the block dot the distance. This is the dot product between this vector here F and vector x, which is the distance. So by definition, F dot x is equal to the magnitude of the force times the magnitude of x times the cosine of the angle between F and x, and we call it theta. You can see that F is pointing to the right and x also is parallel and pointing to the right, okay, so the angle between them is 0. So the work now is equal to the magnitude of F, okay, times the magnitude of x, which we just call x, and then we have cosine 0. But cosine 0 is equal to 1. So in this case, the work is equal to the force times x, the force times the distance. Now, you can see that the block is moving to the right, and the force is also pointing to the right. So the work done by the force F is positive. Okay, the force and x are pointing in the same direction. Now, if we look at the case where, for example, we have now the force of friction. Here is the block, okay, and then we have a force of friction that's working against the motion of the block. So the force F is pushing to the right, but the force of friction is pushing to the left, is pulling the block to the left. So the block, let's assume the block, because this force F is bigger than small f, then the block is going to move to the right certain distance. We can call it x. Let's see, from point A to point B. Now, the work done by the friction, okay, the work done by the friction is W, is equal to the force of friction dot the distance x. Now you can see x, since the block is moving to the right, x is pointing to the right, and you can see that the force F, small f, is pointing to the left. So the block is going to the right. So the angle between the vector x and the vector f is 180 degrees. So now the work is equal to the magnitude of the force, which is F, the magnitude of x, which is just x, times the cosine of the angle between x and small f. And that angle is 180 degrees. So I put here 180. But this is equal to -1. So the work here is equal to minus fx. So this work is negative. Why? Because the block is moving to the right. So the force is pushing, this force big F is pushing it to the right. But the force small f is actually trying to slow it down or trying to block it from going to the right. So that work is opposite the direction of x. So that work is negative. Now, if you have some force, okay, and let's take, for example, this force is the normal force. So we still have the force F, and there is the weight mg, and now we have the normal force is pointing up. So this normal force here is not pushing the block to the right. And remember, this big F here is pushing the block to the right. So this normal force is actually perpendicular to the position, or perpendicular to the direction of the distance x here. Now the work done by this normal force will be equal to the force, which is the n, vector n, times vector x, n dot x. Now this work is equal to the magnitude of n times the magnitude of x times the cosine of the angle between n and x. And you can see that the angle between n and x is 90 degrees. So now we have W is equal to the magnitude of n, the magnitude of x, times the cosine of 90 degrees. But the cosine of 90 degrees is 0. So this is equal to 0 because we have 0 times nx. So the work done by n on the block is 0 work. There is no work. So the normal force, which is a force from the table or from the floor acting on the block, is 0. It didn't do any work. It didn't help move the block from point A to point B. So that work is 0.